Java is now significantly more open. It used to be, like most major projects like that when you open source, what you did was go and work on it on your own little cave. And when it was full and ready, you just present the code ready-made to the world. That has been changing over time. And we're now at the point where the planning, the development, the discussions about whether a feature should be contemplated at all or should be included in the language, all of that is being done in the open.
Hi, this is Satnam Bharti and welcome to another episode of TFiR Insights. And today we have with us Aurelio Garcia-Ribeyro. You are Senior Director of Product Management at Java Platform Group. First of all, welcome to the show.
Thank you.
Let's talk about Java 14. But before we talk about Java 14, I just want to, we are in 2020. What is the significance of Java in today's cloud native world where we're also doing a lot of edge computing? Because traditionally Java is seen as, very heavy, very monolith kind of, architecture. So talk about that a bit. Java,
although some people may not know this, is the number one development language for the cloud as well. I would love to be able to take credit and say, oh yeah, we've been working really diligently to make Java perform perfectly with, we predicted the cloud. Not quite. The thing is, the characteristics that make Java a very robust and good language for the enterprises are indeed the same characteristics that allow us to produce something that's really good for the cloud as well. So Java has been multi-threaded from the beginning. Java runs in many different environments, and it isolates you, if you will, from hardware. An application written in Java will work pretty well with different operating systems, different platforms, on large servers, on smaller servers. And even though most servers now are pretty big, when you start constraining your systems and saying, okay, I've got a huge, massive server, but I'm going to run this on a small image that is constrained by memory, has the memory and the processor's constrained, you end up in something similar to what we were trying to target with smaller devices 25 years ago. So we've, in part by luck and in part by making good decisions, landed on a situation where Java is uniquely well suited for today's modern environments.
Let's talk about the evolution of Java and the latest release, which is 14. So can you talk about some of the highlights or the features that really make sense in the kind of use cases or workloads we are talking about?
So JDK 14 is another one of the 6-month releases that we've been producing since the release of JDK 9. As such, it no longer has what we had in JDK 9 and below, a huge list of 100 plus major enhancements with 3 or 4 high-level massive changes that are going to rock everybody's development world. What we have instead is continuing the pace of innovation. Now, with JDK 14, we are delivering some of the features that came out from Project Amber. We are introducing some new changes to the language. So it'll make writing code simpler. That includes things like switch expressions, which was a preview feature in a prior release, but is now part of the standard. We're introducing 2 new previews. We have pattern matching for instance of, and the one that most people talk about now is a preview for records, which is a way of having the Java compiler create for you behind the scenes most of the boilerplate that you needed to create when you were writing a class that was just a repository for immutable data. Then we have a second preview for text blocks, which is the ability of writing string literals that comprise multiple lines without having to concatenate them by adding, plus, line break, and divisions. Just write it exactly as you would and say everything between these 2 delimiters is considered part of the string. We've previewed that feature before and we received some very useful feedback from the community. That's the reason why we do these previews, right? we think that a preview feature is solid, good, and for all intents and purposes, ready to go. But since once you put it into the standard, it's impossible to change it. We feel that we need some real usage, some feedback from real world usage before we're comfortable saying, okay, this is now the standard. So we've been proven right again, and hopefully text blocks will be slightly better because of the feedback that we received on that JDK 13 preview and from the expected feedback from JDK 14. Then we have new tools. We have an incubator tool. It's a packaging tool that will allow you to package your Java application so that it looks like a native application. Up to now, when you deploy a Java application, people are used to giving you a jar file that contains a bunch of Java classes. And then when you run it, it doesn't look or feel like a native application. If you're running on Windows, you don't have an entry on the start menu. It's not listed on the add remove programs. And the tools that administrators use for deploying them are not very well suited, right? The tools expect to get an MSI installer for Windows or an RPM package for Linux. Now with the new packaging tool, you can grab your Java application and wrap the pieces of the Java runtime that you need, plus your application, put all of this in a nice package that looks like a native application for each platform and distribute that. So we're working on different fronts. We also have some interesting improvements in how we handle memory. We have a new foreign memory access API, which is the child, or if you will, the first feature that comes out of Project Panama. And it's trying to give you a standard API for doing things that previously people used SandMisk and Safe for, right? We have non-volatile mapped byte buffers, some improvements on G1, it's now NUMA aware, and we are introducing CGC, the zero pause time garbage collector, which was previously available on Linux. Now it's being added to Mac and Windows. Finally, for those of you that were using Flight Recorder, the model before it was you create a recording, and once your program stops, you grab that recording and you analyze it in batch mode, if you will. Now with TFiR event streaming, you can analyze and monitor JVM running in real time. So as you can see, even though it's one of these, it's not as huge as 9, there's a lot of goodness packed into JDK 14.
You mentioned that feedback plays a very critical role in each, release. I'm curious that, can you talk a bit about the point when you start, when you release a beta or alpha and you start collecting feedback, how that process works, how do you filter, hey, this feedback is valuable, this feedback, hey, we don't care about that. And at the same time, in general, overall, what has been one of the either pain points or feature requests for this release? So
first, you asked about the feedback process. As you can imagine, it's very challenging, right? Because most developers, they're very busy. They don't have time to go and spend a few hours or maybe even a few days playing with things that don't exist, will probably not exist for a few more months, right? And what we're proposing now might change. This has always been a challenge. This is the reason why we introduce preview features and incubator modules so that we can gather feedback more efficiently. There's a separate challenge, which is in the past, we had these massive releases. So we would ask people to test an early access build of JDK 9, and that would include hundreds of features. So there was always something that would be interesting to every developer. Now, when we ask for feedback on punctual features. That's, it's a mixed bag. On the one hand, you can no longer just grab something and say, everybody should try this because this is of interest to everybody. On the other hand, the people that are interested on a feature appreciate the fact that now, when I grab an early access build for, say, Valhalla, it's focusing only on the changes that are on Valhalla. And if there's any problems, it's not caused by some other random interaction. So we get feedback at all times. As you can imagine, by the way, the most useful feedback is the one that comes earlier in the release when we're still working on the planning of the feature. Second most useful, when we have some working prototypes, but we haven't yet burned it in. And useful, but not so much, once it's ready and it's baked in, that's when you start getting all of the people coming out of the woodwork saying, hey, wouldn't it be great if you did this or that, right? Now, by the way, the last type, that's the one that we used to get the most of, right? With the old monolithic releases. Now, with the projects dropping new functionality into every release, we're getting more useful feedback. And the idea of the preview features is to take it one notch further up, right? It's not just that you have to go and find these, let's say, very specialized, let me find the early access for Valhalla. Now you can test and preview features with the GA version of JDK 14. It's always a challenge. We don't want people building something on top of something that's impermanent. And that's why the preview features have a flag, and you cannot use them at compile time nor at runtime without passing that flag. So let me say, we always want more feedback, but it's working as good as we could have hoped for. And you can see it by virtue of read at what has changed on text blocks, second preview. You can see that there's some changes. You will look at them and you'll be like, well, that's a minor change. Just, like, spoiler alert, there are no minor changes. Everything interacts with everything. So even minor changes are a lot of work. And we are getting good feedback, but of course, we want more. So you've touched on a pet point, right? We go out into conferences and we usually talk to very technical developers and we ask for feedback on new features. And there's a lot of people that come back later and tell me, well, I'm not that technical. I don't understand these memory management, the like, right? Here's another thing that I've asked. Everybody can grab the early access of the next release and just use it to run their current workload on that new release before it comes out, right? So there's no excuse for not providing feedback at that level. Right now, you get to choose feedback for the features or feedback for the whole new release coming out. I'll give you a pass if you're not going and downloading Valhalla, but we need you to go and test the early access of JDK 15, which is already available, right? 14 hasn't come out yet. It's coming out next week. The early access of 15 is already out there. So grab that, give us feedback. We care at all levels, especially this used to work and it doesn't anymore, right? That's the one that we want your help on.
You mentioned two projects, and I just want you to explain a bit about these projects for those who don't know. One is Panama and one is Amber, and then we'll talk about in detail. So can you just give us a quick intro about what these projects are all about?
The way that we develop new features in the JDK, it's some people think that, you just released JDK 14, so you're all in some dark room planning on the new functionality that's going out on JDK 15, right? That's not how it works. The features that we're delivering in any of these releases take much longer than just 6 months. And we don't plan in advance, let's get this feature into this release. What we do is we know there's certain pain points and things that we want to improve. So we've got the smartest people that we have in the teams working on those problems and evolving those capabilities. And as they discover new things that could be useful, we get pieces of that improvement into every feature release. So when I said Project Panama, I don't know if you've ever had to code a Java program that interacts with a native program. And up to now, we have something called JNI. And if you have used JNI, let me apologize, because it's clunky. It's hard to use, right? It's a very high bar, and it's easy to get it wrong. So the problem with that is that you are missing out on a lot of very good libraries that are not written in Java, but that could be leveraged by a Java application, especially now in machine learning, right? So what we're trying to do is to make these much simpler to use so that you can interact between native libraries or libraries written in any other language and Java programs. And Project Panama is working slowly to try to make that possible. And don't expect us to produce here's the release where Project Panama comes to fruition, and all of a sudden here's this fully grown new way of interacting in, say, JDK, I don't know, I'm going to make up a number, JDK 17. No, it's going to be, hey, there's some enhancements going into 14, right? That's that new API that I talked about for foreign memory access. And then you will see some other improvements and some tools for helping you extract the interface from a C library and make it available to Java. That's the kind of work that we do. So that's Project Panama. Another project, the one that nowadays is the one that most people talk about, is Project Amber. And the goal of Project Amber is to find places where we can simplify the ceremony of the Java language without compromising on the readability or readability. Thank you. And that's where things like records or text blocks come in. And we find places that developers are writing boilerplate and that make the code harder rather than easier to read, and try to optimize for that. Now, we're now talking about Project Amber, and it's the hot topic because JDK 14 is delivering a lot of fruits from Project Amber, but we've been working on things like this for a long time. JDK 7 had Project Coin, which delivers similar improvements. And we don't, it's not like, we're done with 14, or when these features are done, we're done. We will continue trying to tackle these problems. So rather than saying, these are the new features we're working on, these are the areas that we're focusing our efforts on. We also have other projects like Valhalla, which is trying to make sure that the way that we handle the memory allocation of Java corresponds with the new hardware and not the old way of doing memory allocation.
You did mention these two projects, so what is the kind of either the development process or the cadence, or what are the new exciting thing that you're expecting from these projects?
It's always a dangerous proposition for us to try to predict what are the new things coming out. I mean, the only thing that's pretty safe is the things that are now in preview mode. We still continue to work to tighten them up and make sure that they're ready for the next feature release. And I don't mean, hey, if you preview it on 14, it's going to be there on 15. As text blocks prove, it can be previewed more than once. And we're just working towards solving these pain points. If you want to see some of the potential improvements, you can probably go online and find a video of Brian Getz during Oracle Code 1 2019, doing a pretty cool demonstration of some of the improvements that are coming from some of the projects that we're working on, right? And he went and changed some product to use Valhalla prototypes, the value type prototypes, right? And you can see a massive performance improvement. Now, of course, it was a project chosen to showcase that. Your mileage may vary if you try it on your own systems, but that's what we're going forward, right? We want to deliver these incremental improvements. Every now and then we will deliver something more massive, but the total addition of all of these will have a substantial impact. And if you think that these are minor incremental improvements, all you have to do is compare JDK 9 with JDK 14, right? You could have interviewed me in each one of them and say, well, 10, it's nice. Where's the big bang, right? Where's the big bang in 11? If you compare 9 and 14, there's your big bang, right?
Right. I want to go back to the first question that I asked, and that was, the significance or importance of Java in today's, cloud world. But at the same time, you also mentioned machine learning, a lot of other workloads also. So what role is Java playing in the modern application development landscape?
Well, we're trying to provide developers with the tools to address the workloads that exist today and that will exist in the future. So we've been talking about these projects that exist, right? You have to take a step back and say, how did we choose those projects, right? Why are we focusing on those areas? And they have to do exactly with where do we see the problems today for developers. So we're working on things like how to make Java friendlier to containers, right? One of the things that has changed is the previous deployment model was I had this monolithic Java runtime. And we had many applications that were using and sharing that same runtime. And that's what the runtime always had to be complete. Modern applications, on the other hand, are usually not deployed that way, at least some of them, right? You have an image and you're going to run that. And if you have 3 processes, you probably have 3 different images. They don't share a runtime. So why do we need a massive Java runtime that provides capabilities that your application don't need? Now, with things like JLink, you can carve out the pieces of the runtime that your application doesn't require. And for the purposes of your application, nothing has changed, right? It's Java as usual. But the runtime is smaller because it's not shipping along or loading all of the pieces that you were not going to use anyways, right? We also make it so that you must be aware when you give Java bytecode to a Java virtual machine, the Java virtual machine converts it to machine instructions based on the architecture and the characteristics of the machine on which it's running. So the same bytecode will produce very different machine instructions if it's running on a machine with a lot of memory and a bunch of cores, and it can take advantage of that, versus a small constrained machine with only a couple of cores and restricted memory. Now, the JVM used to inspect the hardware and figure out, okay, this is what I have to play with. We've worked to make sure that, hey, maybe the hardware has all of that, but the container is constrained. So, even though the hardware has a bunch of cores, you only get to play with this subset, and you can only use this much memory. And we're always working to improve things like that.
What kind of resources are there for the community to not only learn about, what's the new Java enhancement, but also, also get involved with the feedback process and, in whatever way they can participate and contribute to the project?
One of the things that has changed dramatically since the time I joined Sun back in the days is Java is now significantly more open. It used to be, like most major projects like that when you open source, what you did was go and work on it on your own little cave, and when it was full and ready, you just present the code ready-made to the world. That has been changing over time, and we're now at the point where the planning, the development, the discussions about whether a feature should be contemplated at all or should be included in the language, all of that is being done in the open. So every now and then I'll get somebody that come and ask me, hey, what's the secret scoop, right? Tell me, I want to be in the know. What is it that you're working on? And my answer is, I'm sorry, there's no secret scoop. Go to OpenJDK. Every one of these projects has a mailing list, right? And if you are interested in having your voice heard, I could come up with an elaborate, hey, here's my Twitter handle, or here's my email, send it to me, and let's cut all of the middlemen and go straight to the right people. Go to that mailing list. Here's my recommendation though. Don't just go in and pop in and say, oh, I've got a great idea. Look at what has been said, right? All of these things have been, have very smart people that have been working on this for a very long time. Many times the answer to a question is, look at the archive. We've had 4 months of discussion on whether we should do exactly what you're asking, a few months ago. So go read, get informed, and once you understand that, weigh in and say, well, here's what I think. And if you're not comfortable, that's why I said, if you're not comfortable with discussions at that level, You can also go and grab, say, the early access builds. And at that point, we're more interested on operational, give us feedback. Is the performance working? We have paths for every level. Here's the other thing. You mentioned Java is big. Okay, I don't know how big you think it is, but it's bigger, right? You do not have to be an expert in Java to provide very useful recommendations, right? We have people that are experts in internationalization, and they may not feel comfortable talking about garbage collection algorithms or compilers, but hey, there's an alias where all we talk about is internationalization. Go and bring your expertise there.
Aurelius, thank you so much for taking your time out and explaining about Java's importance to the word, and also the whole process of not only the feedback but also the project like Amber and Panama. It was an excellent discussion. I really appreciate your time, and I look forward to talking to you again. Thank you.